Alright, so welcome to our quick notes on 12.6 on spheres. And so we're going to go kind of quick here. Basically, we're going to do surface area and volume of spheres. For surface area, it's a little bit longer to explain why, and so I'm not going to go through the whole derivation. Surface area, the outside of the sphere, this is not a proof at all, but if you think about a baseball and you unwrap it, what you see is we pretty much kind of have, this is not a proof, 1, 2, 3, 4, and again, not a proof, but like 4 circles. And so the surface area of a sphere is basically just equal to 4 of these circle areas. So 4 pi r squared. Okay? Not a proof at all, but if you want to visualize it, think of it like unwrapping that ball there. It produces a circle here, circle here, circle here, circle here, 4 pi r squared. On the Google Classroom, if you check this link out here, there's another explanation for that. Okay, volume though is another matter. We can actually kind of figure out the volume formula. Okay, so the volume formula, by the way, is this really kind of like crazy sounding. Volume equals 4/3 pi r cubed. Okay, so again, surface area 4 pi r squared, volume 4/3 pi r cubed. Where does that come from? It actually comes from pyramids. I'd like to show you a quick video about where we get that from.
4/3 pi r cubed gives you the volume of a sphere. But where does the formula come from? First, we'll draw a perfect sphere and fill in its volume. Next, we will divide the sphere into equal-sized pyramids with square bases.
So again, if we add up all these different pyramids, we would get the total volume. Let's see why it's 4/3 pi r cubed.
So let's take a look at one pyramid, and remember that its volume is equal to 1/3 area of the base times height. Now let's quickly show that the height of all the pyramids that make up the sphere is actually equal.
What is the height? What is this thing right here? It is
to
just
the
the
radius. So our equation becomes 1/3 area of the base times radius. And we will simplify this equation by replacing radius with r and area of the base with b. We will be numbering the bases, so we start with base 1, and our equation is base 1 r/3. So in order to find the volume of the sphere, we simply have to calculate the volume of the pyramids and add them together, giving us a simple formula. So lining up the pyramids, we start from the beginning, and we have volume of the sphere is equal to base 1 r/3 plus base 2 r/3 plus base.
Again, what he's doing is we're adding up all the different pyramids that together would make up that sphere. Adding up all those pyramids together is going to give us the entire area of the volume of that sphere. This is kind of like what calculus is. Breaking things up into infinitely small pieces and then kind of combining them together.
Base 3 r/3. And we will continue this process up until the last pyramid. Now we don't know how many pyramids we have, so we just let base n r/3 simply represent the last pyramid. So having added up the pyramids together, we have this complete simple formula to work with. So next, we will use algebra and begin by factoring out a 1/3, and we will also factor out the radius, giving us r/3 times the sum of all bases. So now let's concentrate on the sum of all bases, and remember, these are the bases of the pyramids that make up the sphere.
So what do you think this is? If you add up all these different bases, what does that give you conceptually?
And as you can see, the bases actually form the surface area of the sphere. So the sum of all bases is equal to the surface area, which is equal to 4 pi r squared. Now, a quick explanation for why the surface area is 4 pi r squared is first we'll look at our sphere,
I'm just going to skip
the
this.
sum of all bases with 4 pi r squared. Now we combine the r's together to get r cubed, and now we simply rearrange the equation to get 4 over 3 pi r cubed.
Okay, so again, this is kind of a strange looking equation. Where's 4/3 pi r cubed? Again, just to summarize, the volume is simply equal to all of these tiny pyramids. Pyramid 1 plus pyramid 2 plus pyramid 3, all the way up there. And so again, each of these pyramids had a height of the radius, right? The height is the radius, okay? Their base, again, this thing we call this like B1, this is B2, so on and so forth, all the way up to Bn. So adding up all these pyramids would give us the volume, okay? And so again, what we have is add up, 1/3 base times height, 1/3 base times height. Remember, the height is radius. Add all these up. Total, that would give you the volume. Remember, he said we could factor out this 1/3 and factor out the r. So basically, you're factoring out r over 3, right? That's the thing that they all have in common. And you're left with B1 plus B2 plus B3 plus ... all the way to Bn. Right? In algebra, you can factor this out. And so again, we said what's B1 plus B2 plus what is, if you add up all these things, that simply just gives you this outside surface area, right? That gives you the surface area. And if we combine and turn this into the surface area formula, which we said was 4 pi r squared. Again, what we can do is just multiply straight across. So r times r is going to give us r cubed. And so we're left with 4 over 3 pi, and then r squared times r, pi r cubed. So there it is. That's our volume formula, 4 over 3 pi r cubed. So the rest of this is really just practice. Let's go ahead and turn to the inside here. Okay, let's try a few. Find the surface area and volume. Okay, so let's say our radius is 5 feet. Okay, so my surface area, again, is just going to be 4 pi r squared. Okay, 4 pi r squared. So just say 4 times pi times 5 squared. 5 squared is 25. 4 times 25, we get 100 pi feet. And then the surface area, again, is two-dimensional, so feet squared, which is 314.2 feet squared, approximately. Okay, so surface area, again, is 4 pi r squared. Volume, again, is three-dimensional with that strange formula. We just kind of went over where that comes from. 4 over 3 pi r cubed. So 4/3 pi times 5 cubed. Remember, cubed means 5 times 5 times 5. It's not 5 times 3, right? So you can say on your calculator, you could just say 5 times 5 times 5, right, 125. Or on your calculator, the way to do it is, where is it for a second here? This exponent here, this caret. Sorry, some calculators have a y to the x button. So we can just say 5 caret 3, right? 5 to the third power, this caret right here. 5 times 5 times 5, 125. Okay, so we get 4 over 3 times pi times 125. Okay, and now to combine this, I like to put this over 1 and just kind of you can either try to divide 125 by 3, which you can't, or multiply 125 times 4, which we can, and we get 500 pi over 3. And this is fine. You can't, 500 doesn't divide by 3, you could just say 500 pi over 3 feet cubed, punch that in your calculator, 500 pi over 3, about 523.598, so 0.6. 523.6 feet cubed. Okay. Go ahead and pause the video. Try to do number 2. The diameter is 24 centimeters. Go ahead and pause the video. Okay, so I'll just show our answer here to speed us along. So our surface area is 4 pi r squared. Our radius is 12. So 4 pi times 12 squared, which is 144. 4 times 144 is 576. You could say 576 centimeters squared. Centimeters squared. That. And punch in your calculator, about 1809.55 centimeters squared. Okay, again, volume is 4/3 pi r cubed. Cut off here. Pi r cubed. And so our radius is 12. So 12 times 12 times 12. You could say 12 times 12 times 12, 1728. Or you could say 12 at caret cubed. So 12 to the third power, 12 times 12 times 12, 1728. So 1728 times 4/3. Again, how do we do this? You can just multiply 1728 times 4. So 6912 over 3. Again, we can try to divide this by 3. You would get 2304 pi centimeters cubed. So 6912 over 3 is 2304 pi centimeters cubed, or punch on your calculator about 7,238.23 centimeters cubed. Okay. Okay, let's do a few more here. Number 3, let's do a composite figure. Okay, so again, the volume, it's not like surface area. We have to worry about things being covered up, right? Volume, you just find the volume of this guy, find the volume of this guy, and just add them up. Okay, so let's do that. So first, let's do our sphere here, except this is actually a half sphere. It's called a hemisphere. Okay, so it's going to be half of the volume, right? So our volume is going to, again, normally 4/3 pi r cubed, but we're only going to take half of that. Remember, instead of dividing by 2, you can take this and multiply by 1/2, right? Multiplying by 1/2 is the same thing as dividing by 2. And so this would give you a formula for the volume of the hemisphere, basically just saying, hey, I could just change this to 4/6. 4/6. Or you could divide 4/2 and get 2/3, right? 4/6 is the same as 2/3. So this is a little bit more simplified. 2/3 pi r cubed instead of 4/3 pi r cubed, right? It's half the volume. Now, we already did the problem with the radius being 5. Right? The radius is 5 here, 5 meters. So again, 5 times 5 times 5 is 125 in the problem up there. Okay. So again, I'm going to multiply this by 2, and I'm going to get 250 pi over 3 feet cubed. 250 pi over 3 feet cubed. Okay, so again, you could half it in the beginning, or you could figure out the answer as 500 pi over 3 and then divide it by 2. Okay, that's this hemisphere. Now for the thing underneath, remember, what is this? You have to remember, is this a prism with 2 bases, or a prism cylinder, excuse me, prism or cylinder, or is this a cone with 1 base? Well, there's 2 bases here. This is a cylinder. So you have to remind yourself, okay, is it B times H, or is it 1/3 B times H, right? B times H or 1/3 B times H. Remember, 1/3 is for the pyramids. This is B times H, area of the base times the height, okay? And so I just need to find this area here of this circle. Again, our area formula is pi r squared. Area of the circle is pi r squared. Pi times 5 squared, or 25 pi. Right? I'm going a little bit fast. You can always pause the video to write something down. All right, so area of the base is 25 pi. The height, how high that is stacked, is 8. So 25 pi times 8. 25 times 8, it's like 8 quarters, it's $2. It's 200 pi. 200 pi feet cubed. Okay, so our total volume, again, it's not like surface area, we have to worry about things being covered up, it's just add up this plus this. So the volume of the total equals 200 pi plus 250 pi over 3 feet cubed. Okay. If you wanted to make this all as one fraction, remember you can multiply by 3 over 3 and get 600 pi over 3 and then add them up and get 850 pi over 3, right? You multiply by 3 over 3 and get 850 pi over 3, or just punch it in your calculator, we get approximately 890.12 meters cubed. Okay. Now, let's take a look at this one. This one's interesting. Why don't you try this one? So what we have here is a cylinder, except this time this volume of this hemisphere is scooped out. So this one you are going to use a subtraction problem. So again, pause the video and see if you can figure out this volume here. Okay, so if we take a look, so again, our radius is 2. The volume of this cylinder, just pretend like it was just a regular cylinder, is base times height. So pi r squared, so 2 squared is 4, right? Pi r squared, so 2 times 2 is 4. 4 pi times 2.5. 4 pi times 2.5 is 10 pi, right? That's for this cylinder. Then for this hemisphere, the thing that we're scooping out, I called it a dome here, but it's really the hemisphere. It's half of whatever the sphere is. So let me show you where this got here. So the sphere, if it was a normal sphere, again, is 4/3 pi r cubed. The radius is 2. So 2 times 2 times 2, 2 cubed is 8. 8 times 4/3 is 32/3, right? So again, if it was a full sphere, it would be 32/3. However, I only want half of 32/3, so I want 32 over 6. 32 over 6, you can simplify by dividing by 2 over 2 and get 16 over 3. Or you could just divide by 2 over 2 over here and just turn this into 16 over 3. 16 pi over 3. Okay, so again, the cylinder is 10 pi. The part we're scooping out is 16 pi over 3. So our total is 10 pi minus 16 pi over 3 centimeters cubed. Or about 14.66 centimeters cubed. Rounded it to the 10th here. Okay. So I'd like to wrap up by doing one more problem here. And actually 2 more problems, excuse me. This one's a little bit interesting, so let's take a look here. Something new on your calculator. We've done a problem like this before, but basically I'm giving you the answer. The volume is 72 pi inches cubed. Find the radius, round it to the 100th place. And so what we've learned, what you're going to practice today, is when you have a problem like this, so it's different than normal, you're finding the radius, you're given the volume, let's just write out their relationship. Volume equals 4 over 3 pi r cubed. Okay, that's a relationship. Let's go ahead and plug in the fact that the volume is 72 pi. Sorry, 72. Okay, and I'm trying to solve for the radius, and we're just going to use algebra. Okay, we're going to save this exponent for the last. Let's get rid of this 4/3. How would I get rid of a multiplying by 4? How would I get rid of multiplying by 4? Just algebra. That means I'm going to divide by 4. But do the opposite. How do I get rid of dividing by 3? Well, I'm going to multiply by 3. Right? So what I can do is, again, to get rid of this dividing by 3, I can multiply both sides by 3. To get rid of this multiplying by 4, I'm going to divide both sides by 4. But instead of doing it in 2 steps, which is totally fine, you can multiply both sides by 3, divide both sides by 4. I'm going to multiply by 3/4, right? You notice how I'm multiplying by 3 and I'm dividing by 4. This is kind of getting rid of both these numbers in one shot. So this is a trick in algebra, right? If you want to get rid of this fraction, just multiply by the reciprocal, right? Multiply by the reciprocal. The 3 over 3 becomes just a 1. The 4 over 4 becomes just a 1. And so we're just left with pi r cubed over here. Okay. And 72 over 1 times 3/4, so thinking about that. So 72 divided by 4, 72 divided by 4, well, let's see, 72 divided by 2 is 36, divided by 2 again, that gives us 18, or you just punch in 72 over 4. Right? 18 times 3 is going to give us 54. 18 times 3 gives us 54. Okay. So how do I get this r by itself? Still have to clear out the pi. So let's go ahead and divide both sides by pi. That's just a number, right? 3.1415. So divide both sides by pi. So I'm left with r cubed equals 54 over pi. So how do I get rid of this? If it was a squared, right? If it was like r squared equals 16, right? We square root it, okay? So what we're going to do is something called a cube root. It's like a square root, but it's like the inverse of a cube instead of a square. So think about a cube root. A cube root, the symbol, by the way, is this. It's a 3 with this root here, right? This is called cube root. Cube root. Okay. So for example, it's not the same as square root. The cube root of 27 is what? So you think to yourself, what number cubed gives you 27? What number times itself 3 times gives you 27? Well, that's 3, right? Because 3 times 3 times 3, 3 cubed equals 27. So again, cube root is like the opposite, the inverse of that. You're saying what number times itself 3 times 3 times 3 times 3 gives you 27? That's 3. Okay. How do you do this on your calculator? What it is it's this blue one right here, this x root. So it's a little bit confusing. What you do is you type a 3 because you want a cube root instead of a square root. Push the second x root here. So cube root of 27. Cube root of 27. Push enter and it says 3. So that's the number. 3 times 3 times 3 is 27. Okay. Let's try another one. So again, you put a 3 here. Cube root of 64. Right? So again, what number times itself 3 times gives you 64? That's 4, right? Because 4 times 4 times 4 gives you 64, right? 4 cubed is 64. Okay, and so we can see that if we punch it in right here. It's a, so push the 3, so second x root right here of 64. 4. Right? Or what about 1,000? What's the cube root of 1,000? What number times itself 3 times gives you 1,000? Well, you could check. It's 10. 10 times 10 times 10 gives you 1,000. So 10 cubed is 1,000. So just this is like the inverse of that. So you're saying what number cubed gives you 1,000? So we type again to check 3 x root 1,000. Saying what number cubed gives you 1,000? Push enter. Oh, that's 10. Okay. How about cube root of x root of 125? What number times itself 3 times gives you 125? 5, right? 5 times 5 times 5 gives you 125. So anyway, just to show you what a cube root is, I'm going to do that here. I'm going to take a cube root of both sides. So again, we're going to use this little 3 here, put the 3 root here, 3 root here. So we're saying the cube root of this crazy looking 54 over pi. So what number times itself 3 times gives you 54 over pi? In fact, if you don't have a calculator, you can just leave it like this. This is perfectly fine. R equals the cube root of 54 over pi inches. That's totally fine. Now, most of us like something a little bit nicer, so let's go ahead and punch this in. So again, on our calculator, we're going to type in on our calculator 3 x root, right, that blue one, and then 54 over pi in parentheses. I got a bit in parentheses, otherwise order of operations comes into play in a bad way here. So let's say 3 x root parenthesis 54 over pi. Okay, about 2.58. Okay, so either one is just fine, but this is what they ask for because it's rounded to hundredths place. The rest of the period work on this. Got a lot of problems, but you got a lot of time, so this is your classwork and homework. So go ahead and work on this, please.